Hey there. I'm going to be working on your practice final exam, and let's get started. So problem number 1 is the absolute value of x plus 7 is bigger than 1. Now, there's several ways to teach this. The way I teach my students is here, or the negative version of that. Some teachers tell you to flip the sign and change to a negative there. That's just dividing through by -1. So it's all the same thing. This is the y. So I get x is bigger than -6, or distributing the -1 here, I get negative x minus 7 is bigger than 1. Now, remember when you divide by a negative with an inequality, it switches the direction of the inequality. And the graph version of this would look like this. And because there's no equal to symbol here, we're going to have open circles. Less than -8 is there. There we are. And bigger than -6 is here. And in interval notation, which is what they're asking for in this case, and I'm going to use parentheses again because there's no equal symbol. And we use the union symbol or the or symbol to represent it can be in either set. Number 2. We have 28 or 5 plus root 11. And we're asked to rationalize the denominator, and we're using a rule where I'm multiplying conjugates in this case, meaning they're the same, but one's minus and one's plus. We get this beautiful difference of squares. And so these are called conjugates. And the conjugate of 5 plus root 11 is going to be 5 minus root 11. And because I have this thing going on, I'm going to end up with 5 squared minus root 11 squared. I'm going to leave that 28 out in case it reduces with something in the bottom, which I think it does in this case. So 5 squared is 25. Root 11 squared is just 11. And I'm glad I left that 28 out because it looks like it's going to reduce here. 28 and 14 reduces to a 2. There's 2 ways to write the answer. Like that, or you can distribute it in. Either way is fine. Both work just fine. Number 3. Is a division problem. And we're going to have to do long division. And I now need something times 3x to give me 9x cubed. That's going to be 3x squared. And I'm going to distribute that to both. and subtract. This part should always cancel. 9x cubed minus 9x cubed, 0x cubed, or just 0. 6x squared minus 27x squared is going to be a negative 21x squared. I'm going to bring down the negative 60x. Now I'm going to start again. I now need something times 3x to give me negative 21x squared. That's going to be a minus 7x. Negative 7x times 3x is negative 21x squared. They match. 7x times 9 is going to give me a negative 63x. And then I'm going to subtract. You're going to be careful with all these negatives now. Negative 21x squared minus minus, that becomes plus 21x squared. They're gone, as they should be. Negative 60x minus minus, that becomes plus 63x. That becomes 3x. Bring down 16. And lastly, I need something times 3x to give me 3x. That's just going to be a positive 1. Distribute the 1 here as well. And subtract. 3x minus 3x is 0, again, as they always should be. 16 minus 9 should be 7. So the quotient in this case is 3x squared minus 7x plus 1. And the remainder is 7. Which in this case is how they ask us to write it. Sometimes they'll have you put that over that and add that at the end, but just depends on the questions being asked. All right, number 4 has 2 parts. We have rational expressions here. And when we multiply, we just multiply straight across. And I'm going to go ahead and start factoring as well. So I'm going to factor this one here. I'm going to factor this one here. A common factor of 2. I'm going to factor this one here. And I'm going to factor this one here. We're going to see a lot of things reduce here. We're going to end up with 2 over x minus 1. Now the second part of 4 has a division problem. And if you remember with division, we're going to take that second fraction and flip it, take the reciprocal, and then multiply. And now I'm going to start. Up here, I'm going to pull a negative 3 out. And remember, when you factor a negative out, it changes both signs. You can see I pulled the negative 3 out, so it went from negative positive to positive negative. I'm going to factor that. Down below, I'm going to factor here. Now factor here. And once again, we see a lot of things reducing out. X minus 5, x plus 3, x minus 1. Ah, that stays. That goes. We're going to keep this one. So that's not right. So we end up with negative 3 over x minus 1. And you can have the negative up with the 3 or on the side like I have it here. So this one's not crossed out. Okay. Use your imagination a little bit. So once again, I flipped the second fraction. I factored it, pulling a negative 3 out. Factored here, here, and factored here. And then reduced everything out. This one's not canceled out. That stays. Yeah. Number 5. There's a couple of approaches to this one. I'm going to turn 64 into 2 to the 6th power. I'm going to verify that. 2 raised to the 6th power is 64, so I was right. And if you recall, when you have a power raised to a power, that means you multiply the exponents. And you'll notice I have the same bases here. So because I have the same base, that means that the exponents are the same. We distribute the 6. And because I have an x by itself over here, I'm going to go ahead and move that the 6x this way. I'm going to note I have a negative over negative, so that means x is going to be positive, and 30 over 4 reduces to 15 over 2. Number 6 is a little messier. Now, unlike the previous one, I can't turn that 13 into a 2 to the power of something. So I'm just going to flat out take the logarithm of both sides. Now, when I do that, I to use either the common log or the natural log. I like natural log, so I'm going to use it. You can use the common log, you'll get the same answer. And one of the log rules is, if I have an exponent with a logarithm, it comes down in front, becomes multiply. And I'm going to notice that I can actually divide both sides by ln of 2, the natural log of 2. It's not the only way to do this problem, but it's the way I'm going to choose to do it. Now to finish solving for x, I'm going to add a 3 to both sides. And it looks like they want both answers. Here's the exact answer. And the approximated answer is going to be here. Ln of 13 equals, divided by ln of 2 equals plus 3. They said to go to 4 decimal places, so we went to 4 decimal places. Number 7. Here we have the log base 4 of x plus the log base 4 of x plus 2 equals 7. And when I have this, when I have addition, that tells me that I actually need to turn that. So I'm going to take that x and multiply it to the x plus 2 as I make it all one logarithm. And now I'm going to change it from logarithmic form into exponential form. Here we are. 4 to the 7th power. That is a crazy big number. Ugh. And because I now have a quadratic, I got to get the whole thing equal to 0. And now I'm going to have to use quadratic formula. A is 1, B is 2, and C is negative 16,384. There's the quadratic formula. I'm going to drop everything in. Now, I want to keep in mind, notice that Notice that I have a negative times a negative. That's going to make it plus. And I'm going to add 4 to that. And I'm going to come up with a couple of decimal approximations with that. Two plus the square root of 6, 5, should be a 5. 6, 5, 5, 4, 0. Divided by 2. I'll double check that. So 4 times 16,384 plus 4. And then we double check that. 4 times 16,384, 384. Let's try this. Plus 4. So So negative 2 plus the square root of 65540 divided by 2. There we go. That's, I must have, I think I did a positive 2 instead the last time. 127.0039. If I do negative 2 minus the square root of 65540 is divided by 2, I get a negative 129.0039. Now, we can't take the logarithm of a negative value. Watch, log of negative 7. We get an error message. So if I plug that into the original, we're going to have a problem. So the only answer is going to be this here for number 7. All right, number 8. Number 8 is a quadratic. And I don't like that negative in front there. So instead of moving the 66 this way, I'm going to actually move both of these that way. And this one very nicely factors for us. And we actually can have negative numbers on a problem like this. The previous one had logarithms involved, so we couldn't. Next up, we have number 9. And we have another quadratic. And for this one, we're going to use quadratic formula again. This one should be a little simpler, but we're going to have a little surprise here. Be careful the negative, negative 2, because b is negative in this case. That's going to be minus 28 over 2. Now, we have a small surprise in the sense of we have a negative under the radical, which is okay now. I can simplify it. With the I. And you'll note up top, I can factor a 2 out. And you'll note that the 2's reduce. This would be okay for me. Your online system wants to see it like this. I just want to really caution you, be really careful when you're putting this in. Make sure that I is not under the radical. If it's under the radical, you'll be marked off. All right, number 10. Now here I have a radical by itself, and what I'm going to need to do is square both sides. I got to be careful on this left side here. Here it gets rid of the radical. Here I have to actually FOIL this out. And there's a rule you can follow, but just make sure you don't just give a square root of the 2x and a square root of the 11. That does not work. Negative 22 times, yeah. So I now have a quadratic. I got to get the whole thing equal to 0. And I'm going to notice very nicely that these are all even numbers. So I can actually divide a 2 out, make the numbers a little smaller for me. Go this way. Half of 130. 130 divided by 2, 65. And I'm going to note that that factors to 2x plus 13, minus 13, minus 13. And then x minus 5. And we have to check these. When I take 5 in there, 5 times 2 is 10. 10 minus 11 is negative 1. I can't have a radical equal to a negative value when we're dealing with real numbers. So x equals 5 is out. But 13 over 2 works itself out. Next up is number 11. All right, I'm going to note that this denominator very nicely factors into that. So because I have an equation, I can multiply both sides of the equation by the LCD, which in this case is x plus 5 times x plus 7. And here the x plus 5s cancel out. I'm left with x times x plus 7. I got to be careful here. X plus 7s cancel out here, but I have a negative 2, and I'm left with an x plus 5 when they reduce out. So I'm going to have to distribute a negative 2 there. Just be really careful. Equals 22x minus 82. Distribute, distributing a negative there. Be careful. I'll note that I have a quadratic, which the whole thing equal to 0. minus, that's going to be 17x plus 72 equals 0. And that very nicely factors for me. Now I have to check. The only values of x I have to worry about at the end is if x is -5, because then I'm dividing by 0, or if x is -7, because then I'm dividing by 0. But I don't get either of those, so both are correct answers. All right. Number 12. So we got some exponent rules we're going to deal with here. 4s to the 4th, 4r to the 6th. And each set of parentheses is going to, each of the exponents are going to get multiplied by whatever the exponent is on the outside. And now I'm going to combine them up, which means I'm adding the exponents. So 4 to the 4th times 4 to the 6th, 4 plus 6 is 10. R to the -2 times R to the 6th, it's going to give me R to the 4th. S to the -2 times S to the 4th is going to be S to the 2nd power. This is fine for me, but they might actually multiply it out. It's going to be a big number. 4 raised to the 10th power. Ugh. It's over 1 million. And they put the big number in front. All right, 13 I deleted, so we can skip it. 14. Given a function f of x equals 7x squared plus 4x minus 1. And there are 5 parts to this problem. 1, 2, 3, 4, 5. Yeah. So part 1, find f of 0. And these go to 0, so I'm just left with -1. Nice. Next up, find f of 2. Problem. Just follow your order of operations, of course. Exponents first, and multiply, divide, and then add, subtract. Next up, f of -2. Remember, when you square a negative, it becomes a positive. However, a positive times a negative gives me -8, -1. Part 4. F of x plus 1. Now I'm going to keep this nice and simple. You got to replace both x's with the x plus 1. And I'm just going to stop there. Some teachers may have you actually FOIL that out, distribute, combine terms. Not me so much. The last one is f of negative x. And if you remember, when you square a negative, it just becomes positive. Now here I have a positive times a negative, so minus 4x minus 1. All right. 15, we are given f of x equals 10x plus 6. And we're looking for f inverse. And change the f of x to a y. And now swap out the x's and y's. And now we're going to solve for y. So our inverse function is x minus 6 over 10. All right, so we are to number 16. Less than or equal to 20. That's a little messy. Let me rewrite that. And I'm going to notice that they're all multiples of 2, so I'm going to actually divide a 2 out. I'm dividing by positive 2, so I don't have to switch the inequality. And now I'm going to put it in the slope-intercept form by subtracting a 5x. Gives me y is less than or equal to negative 5x plus 10. And this graph is going to be a solid line because I have an equal symbol. Start at 10, go down 5 and to the right 1. And there's my straight solid line. And because it's less than, I'm going to shade downward. All right, next sheet. We're to number 17. Here we have the natural log of all right. Now, if you remember, radical is the same thing as dividing each of these exponents by 2. There's 2 right there. Multiply means we're going to change into add. Divide means we're going to change that into subtraction. And the final rule is we're going to bring those exponents down. And that is about as broken down as we can do. All right, number 18 is a word problem. So I'm going to share my screen with you so you can read the word problem. We have an airplane flies 2,351.25 miles into the wind for 19 hours, and the return trip takes 11 hours. Find the speed of the airplane without a wind and the speed of the wind. So we're looking for two things in this case. All right. First off, I'm going to let x equal the speed with the wind, and y is going to be the speed against the wind. And I'm going to set up a table. We're going to use our friend rate times time is distance. And the rate of the plane with the wind is going to be x plus y. Against it, it's going to be x minus y. The wind is slowing it down when it's going against the wind. When it's going into the wind, so when the wind is working, it's going to take 19 hours. And with the wind, it's going to take 11 hours. And they're both going the same distance. 2351.25, 2351.25. And I'm literally just going to go rate times time is distance, rate times time is distance. So here we go. And I'm going to do a little trick here. I'm going to divide both sides by 11 here and divide both sides by 19 here. This trick often works for textbook problems. In real life, it rarely works. So I'm going to go 2351.25 divided by 11. Okay, so this becomes x plus y equals 213.75. Do the same thing here. 2351.25 divided by 19. And now I can actually add these two equations up. Make sure we have enough space here. All right. So if I add these two up, I get 2x. You can see y minus y, they're gone. And 123.75 plus 213.75. I'm going to divide that in half. And the rate of the plane with no wind with no wind. And this is just the speed of the wind. So I'm now going to take this, put it into with no wind. Yeah. I'm going to take this and plug it into here. That's going to give me 168.75 plus y equals 213.75. So 8. So I go 213.75 minus 168.75. Wind, as I subtracted, getting me that y is 45 miles per hour. So here are my two answers. Speed with no wind, speed of the wind. All right, next up, number 19. Root 8b minus root 32b equal plus root 200b. And what I'm going to need to do is simplify each of these, and if they are like terms, I can combine them up. This is 4 times 2, which becomes 2 root 2b. This is 16 times 2, root 16 is 4, root 2b. And this is 2 times 100, square root of 100 is 10. And you can see very nicely that this part is the same for all three. So I can actually combine them up. 2 minus 4 is negative 2, plus 10 is 8 root 2b. Number 20 is another word problem. So I'm going to share my screen with you so you can see what I'm reading. How many milliliters of 7% sugar solution do we need to mix with 48 milliliters of 40% sugar solution so that the resulting mixture is 49% sugar solution? All right, I'm going to switch back. All right, I'm going to let x equal the amount of 73% needed. So there's a total of x plus 48 milliliters of solution, sugar solution, total is what we're looking for. The amount of x that we want, as far as sugar goes, is only 73%. The amount of the 40% is 48. They've already given that to us. Now the amount of the total is a 49%. So this line just represents sugar. You could multiply through by 100 to knock out the decimals. I'm going to leave them in. I don't see a reason not to. So the first one I'm going to have to do is 0.4 times 48. So now I have a linear equation, and I'm going to move the x's to the left, and I'm going to move the non-x's to the right. Giving us 18 milliliters. There it is. Number 21. There are 4 parts to it. We're given a function f of x is x squared minus 4x. G of x is x plus 8. And we're going to do some composite functions, meaning I'm going to put a function into another function. So part 1, part A they call it, that's fine. They want f composite g of x. This means f of g of x. What they're saying is replace all the x's in the function f with x plus 8. This is fine for me. Let's see if they multiply it out or not. They don't for this one. Some teachers may have you multiply that out. That's fine. You just have to FOIL there, distribute the -4, combine your like terms, and so on. Part B says find g composite f of x. So now we're going the other way. This means now I'm going to replace that x with all of that. Not so scary. Part C, we're going to do f composite f of x. Which means I'm going to put the function f of x into itself. There it is. Again, some teachers may have you multiply that out, which is fine. So here we're compositing g into itself as well. Not too bad. Number 22. We have a relatively simple linear equation. And I'm looking at 12 is going to be a common denominator here. So I'm going to multiply everything through by 12. 12 divided by 2 is negative 6x. 12 divided by 6 is 2 times 5 is 10. 12 divided by 3 is 4. 4 times 2 is 8. 12 divided by 4 is 3. 3 times 3 is 9. And just like that, in one step, I can knock out all those fractions. Moving all the x terms to the left, the non-x to the right. And I'm dividing both sides by negative 14. A negative divided by a negative is a positive. Positive 1 over 14. And our last one, number 23. Is some rational. 23. So we're going to have to get a common denominator, but before I do that, I'm going to have to factor. Let me go to my scratch paper off to the side here. 2x squared minus 8. I can factor a 2 out. And then notice I have a difference of squares there. That is my common denominator. And for this fraction, I'm going to have to multiply 2 times x minus 2, 2 times x minus 2. This one I'm going to have to do a 2 times x plus 2, 2 times x plus 2. Got to be extra careful here. I'm going to have to distribute a negative there. Just be careful. Negative 1 times 2 is going to be my negative 2 there. I'm missing a 2 there. So that's actually a 4 that I'm going to be distributing up top. 2 times 2, right? I got a 2 there and a 2 there. Here I'm distributing a negative 2, be careful. And combining up my like terms, 4x minus 2x is 2x, 2x plus 1 is 3x. Negative 8 minus 4 is negative 12. And I'm going to try factoring that numerator, see if anything reduces out. And it doesn't. That is it. I hope you found that helpful. Thanks for coming.